This is Bitnar Talks, the engineer takes on construction. Episode 4. Hi, I'm Piotr Bitnar. Each day I help my clients plan and design building projects through Bitnar Limited, a consulting chartered structural engineer's practice. My biggest passion and the cornerstone on which I've built my business is finding clever solutions for construction projects. I am a chartered structural engineer and a budding software developer, so you can rest assured that I will strive to talk about the best practices and the use of new technologies in the industry. And if you're embarking on a construction project or are involved in planning, designing and building the world around us, you'll find this podcast useful. Today I'll talk about Stage 2, Concept Design. Hello everyone. Welcome to the new episode of Bitnar Talks. A month has passed and I can now claim to be one of the most successful podcasts out there. Well, at least according to some statistics saying most of the podcasts, around 90% of them do not ever go past the 3rd episode mark. So here you have it. This one is the 4th one. I plan to do at least another 17 to achieve and be at the magical 1% of podcasters out there. Apparently, not many of us ever go over the 20-piece mark. So brace yourself and bear with me for at least 21 episodes. Jokes aside, I'm glad you're back here with me in the following week, and I hope you'll find something new and thought-provoking within this episode, as hopefully you did in the last one. In the last episode, you could have heard the 2 different approaches to the preparation of the project brief and how ill-defined decisions and misinformed approaches to the process of project definition and delivery can break the project. In my everyday practice in Bitnar, consulting chartered engineers, I strive to create a process and informations for my clients so they can appreciate how complicated this world can be and show them the value of offices like mine, which combine the expertise and capabilities of now so fragmented industry. I envy such guys like Brunel or Eiffel, who honed the art and skills of the era, engineers who live their projects being capable of delivering all aspects of them, rather than relying on tens of different consultants, which seems to be the case nowadays. Maybe it comes with the time and politics of responsibility, or simply departure from principles in favor of codes and standards. I love principles, don't get me wrong, and that is where I start all my projects. Let us worry about the red tape, codes and standards at the later stage. This stage is the stage of principles of spatial design, massing, structural components and their mechanics, material selection and their interaction with each other and the ground, sustainability and carbon, embodied or operational, of any given solution and the interplay of all of them. Today, I'll talk about the stage that all AEC bears like the most. I think we like it even more than we like honey. Why do we like it so much? It's primarily due to the fact that it is most creative stage of them all. This is the stage where the experience, expertise, width and breadth of knowledge and intelligence come together to define concept designs. And I would like to emphasize the S in the designs. It is not the stage where you simply deliver one design and take it forward. It is the stage to find several ways to do a thing and to compare them and go ahead with the most suitable one. It is the part of the project design process where you like to have the best brains at and allow brainstorms between the team members. If you can get an architect, an engineer, and a contractor in the same place for this stage, you can assure the chosen solution will be the best one forward. So what you'll find in this podcast, I'll talk about what is this stage all about. Then I will move over to things to consider, which I divide in two parts. One is creating the different concepts and comparison of them, and they then taking the one chosen one for further development. I identified 8 points. 3 of them will be the first part of it, and then the next 5 will be the delivery, the definition for the next stage. These are 1, architectural concepts; 2, engineering solutions correlated with the cost plan; 3, the way to deliver, call it contractor view. Then we move to how to approach planning, how to reach building regulations compliance; 6, who should be involved in further definition, responsibility matrix; 7, outline specification; and 8, update the brief according to the achievables defined at the end of this stage. So let's not delay it any further. Without further ado, let's get into it, shall we? So what is this stage? Well, in simple terms, this stage concentrates on the definition of the architectural concept in line with the brief defined in the previous stage. Often this brief needs to be derogated as the conceptual stage progresses to address feasibility studies and the issues identified during the creation of concepts, and perhaps upgrade it with opportunities that we found out during this stage. I think here you can appreciate how important it is to have several different ways of doing the same thing, and how teams should collaborate into defining those different schemes. It's sort of like going online and comparing all different products. However, here you need to rely on the experience and breadth of knowledge of professionals to give you several different solutions for one problem, and then you can go on and compare it by all the different standards, like how sustainable it is, what sort of operational carbon is involved once you build the building, which may be actually better to concentrate on than thinking about the carbon that's embodied within the construction of that building. What are the costs of different solutions and how they impact the end product, and how they impact on brief and funding. There's many things to consider here, really, including layouts and how it's going to look like, whether it's going to be aesthetically pleasing or not, and so on. So the things to consider here while preparing the briefs, the things to consider for the whole stage, as I mentioned before, I consider it to be a 2-part process. One is trying to find the best solution, doing the different alternative solutions for one given brief, and then taking it forward to making a plan for further development in stages down the line. We generally start with architectural concept, which concentrate on the idea development. What is the design intent and party behind it? Party of the chosen solution. So basically, what's the justification for what the architect or designer came with? What's the inspiration for such a building or the neighborhood? How the building or the neighborhood or indeed factory is organized spatially. whether that's aesthetically pleasing or not, what's the aesthetic expression of the whole building. In determining this type of factors, it's vital to be good at sketching and the ways to visualize those. Some people are not that great with hand sketching, so computer-aided design jumps in very nicely, and with the modern techniques and modern AI tools, we can easily go into all different. We can make hundreds of different visually pleasing solutions for any given projects, given it the boundary of space and, well, basically a space. They're not that sophisticated models as of yet, so most of them, they are just space bounded. So, but it gives you a direction, it gives you that possibility to check many solutions and see which one is the one forward. And the trouble with being capable of producing so many different solutions with the modern tools, with AI, is you can get inundated and paralyzed with the number of alternatives. So perhaps sometimes it's better at this stage, at least, to keep it simple. Keep the entire thing into more like a massing, in terms of massing, than claddings and all of the fancy features of the build. It's more important at this stage to think how the building is located in the globe, how it can play with lights, how it will influence wind or be influenced by wind, and what sort of materials to use for its creation, depending where in the world it is, and depending what type of systems we'd like to use. They may be altogether different, and it's important to appreciate and think about this process as an iterative one. So it's not a straight line getting to the solution, it's more like regurgitating information, trying to find the right mass and space for the given brief, and then putting that mass into the perspective of the local area and the sun and the wind and other aspects of the build, and then check whether it's feasible to actually do this for the given solution at the given site, how it relates to the budget, and whether that be possible to actually build within the constraints of it. Check the given solution with the client, whether it's somewhere around what she expected it to be. There are more people involved in the creation of the building. It may be such a large scheme with such a great impact that you'll have to go out there and ask the neighborhoods how it's gonna impact them and what they think about it. They may give you a perspective that you never thought about before, as you don't appreciate the area as much as people who live in their area do. And it's time to assess risks too. So it's important to define the design intent, which is the concept which you can communicate, the overarching design intent of the main idea behind the project. It answers the question of why the building is designed in the particular way and what message or experience it aims to convey. What's the inspiration for the project? You see, concepts often draw inspiration from various sources, such as cultural, natural, historical references, or maybe sometimes abstract ideas. See Zaha Hadid's designs, all of those wavy, curvy, looking like a desert blown by the air solutions. The chosen inspiration helps to create a unique and meaningful narrative for the design. How it's spatially organized, as I mentioned, the concept influences the spatial organization of the building, dictates how different areas and functions are arranged and interconnected with each other. It guides decisions about circulations, hierarchy of spaces, and overall layout. Aesthetics is very important. After all, we like to engage and be around and surrounded with beautiful spaces, beautiful buildings. They like music, they talk to us and resonates with us. And the aesthetic expression of the architecture is really, really important here. How you're going to express yourself will influence the material choices and colors and textures you'll be able to use to achieve that expression. It's very important also to, well, I say important to all of those things because they kind of are all important, and at the same level you have to think about them. The functionality of the building. After all, we're not making monuments, we're making functional buildings, and they have to discharge all of the needs that are created by the business case. You see, while the concept is often associated with that artistic and aesthetic consideration, it also needs to address the functional aspects of the building. The concept should support and enhance the intent, use, and purpose of the building, and maybe find opportunities to make it better than initially thought about. You know, how we need to think how users will experience the building. You see, buildings will shape the occupants' interaction with it and how they perceive it. We need to foster that sense of identity and connection to the built environment. Buildings should be also accessible to all sorts of people and adaptable. In the modern world, we change how we operate our building site. You can see buildings, our cities, our buildings. You can see offices turning into flats, flats turning into hotels, hotels turning into shops. It's all fluid, and if we don't think about how the building can be used in a fluid way, we're not using its full potential. You see, the buildings, the concept of the building should be flexible enough to adapt to various constraints, regulations, and practical consideration while maintaining its core essence. That concept here now will serve as a guiding principle throughout the design and construction process. So that be the architectural part of it, the architectural approach to the concept creation. You see, it's molding the mass to something resembling the final product, or at least a tangible way forward. All of those architectural concepts, and they should be sort of simple at that stage, but giving the sense of direction and addressing all of the different points that I just mentioned. But they should be run through the engineering, through the structural engineer, who can assess on plethora of different aspects of it. You see, paper will take everything, we like to say in the industry. You can put anything on a piece of paper or on a CAD, computer-aided design that is, and it would look lovely. Add it to the AI engine, and you have millions of different solutions that are meaningless. And that's where the engineer comes in to give that skin some bones and meat underneath, right? If you get what I'm saying. The engineer here is to take one of those, to take those solutions, to take the concept or several of them and start looking at them from the physical perspective, the buildability perspective of them. He'll need to think about the choice of materials and early estimate the cost of such a structure. basing it on the preliminary designs, things like rule of thumbs and how the buildings usually come together, and what is the usual size of those elements in different materials. We as engineers, we appreciate that. We've designed many buildings of different sizes and different uses, and we quite well can say what sort of solution will play best role in any given concept. Once we look at the layouts that have been identified or laid down before us by architects, we look at the site constraints, we look at the constraints of layouts and identify potential cost drivers. We usually collaborate with cost estimators at that time too, and financial experts, analyzing historical data and benchmarks for similar projects, so we know that we actually going into the right direction, taking monetary consideration on board. Need to think about the life cycle costs of the whole endeavor. How much it will cost in construction, operation, maintenance and disposal, and try to optimize our solution so it addresses all of those parts. You see, it's easy to just push forward and create anything and just start putting the bricks together to make those walls, to make the building. But if you don't think how this building will, how this solution will influence the life cycle, the cost of that building, of the life of this building, there are plenty of opportunities for sustainable and economical solution lost. This stage is also a stage for value engineering, where we can implement value engineering principles to enhance the functionality, quality and overall value of the project, while, guess what, minimizing the costs. You see, the column can be column in all different materials, but it can be actually better if it's different. If it's not a column, maybe if it's trussed, or maybe if it's something different. Maybe if it's concrete, or maybe timber will do just fine. We need to look at the alternatives to achieve one given concept, but without compromising performance or safety. Now it's the time where we come in and start thinking about what sort of materials we use and give it a preliminary specification. We need to evaluate them on the basis of their costs, availability and performance in that given building. We consider alternatives, compare different properties, and it's all driven very often by the cost and efficiency of that building. You see, efficient design practice is all about optimizing design to minimize waste. It's all about reducing complexity and improving construction efficiency. The more difficult it is to construct on site, it may transpire during the construction that the actual buildability of it is so bad that the building will cost 50% more or more than anticipated at the forefront. We try to utilize standardized solutions, off-the-shelf products, so there's not much of the bespoke going on. If it needs to be, it needs to be, but if it doesn't, it's better to use things that are nearly factory produced, so the cost of the given solution is minimal and there is enough bulk behind that solution to actually make the project viable, safe and cost effective. In the modern world, in the first world countries, labor is one of the biggest costs, if not the biggest cost of any given project. And that's the cost we like to reduce. The less labor on site, it's it's one, safer to deliver the project if there's less people on site or less people involved in creating the building, and two, if the product can be standardized, we can control it better and deliver better standard product, better standard building. It's important to consider energy efficiency and sustainability of any given solution. Integrate the energy efficient and sustainable solution into that concept. However, it may command or incur higher upfront cost, but result in long-term operational savings. And if you don't put that down on paper and have that possibility to compare, you won't really know, and you may be driven by the false economy of trying to make as slim solution as possible, which may not work that well in the long run. It's the time to think about renewable energy sources and use of alternative or add mixtures to the construction materials, thinking about energy efficient technologies to reduce operational expenses and how this can be incorporated within the building. Think about the risk of creating the building, how it could impact the project costs, those feasibility study, whether ground is correct, whether there are floods, whether they need to protect the building from other aspects of the nature, and how we could approach it in future once we develop the project further. Because it's one thing to think about the risk and identify them, and the other thing is to have a plan for dealing with different scenarios once we get them. You see, it may be the case that we'll need to use raft foundation, or maybe we use piled foundation or other solution. It really depends on the ground conditions that we at this stage may not that well understand. Maybe the soil investigation reports weren't that great, and that's one of the risks that you can actually identify and then address it rather than delay it to get better definition of those aspects. You can plan for different contingencies, for different outcomes, different solutions once the proper information comes into play. We need to think about the technology and innovations and how we can apply this. Maybe the good way forward would be to use modern method of construction, modularize the whole build. And if we don't keep ourselves updated with these or design them in the office, how can we know what solution is the best? We may be well suited in providing standard and traditional concrete or steel frame solutions, but it may be better to actually do it in the light gauge steel construction, or maybe timber. Who knows? It really depends on the project. I love to design in all sorts and different materials, and it's a pleasure to be able to do it. But that comes with a lot of effort in keeping up to date with all of the material solutions and how you can actually use all the different materials. And it's not a game for everyone, especially for the small offices. It's quite difficult for a small office to be exposed to all of it unless the office heavily invests in training and research. This is the time where engineer meets an architect, and if they both cannot communicate well with each other, and there can be standstills, there can be difficulties and opportunities missed. It's very important at this stage to carry on communicating with all stakeholders involved to align that project goal with the budget constraints and possible engineered solutions. And one of the things that architects and engineers are not really that well adapted in, but sometimes, well, on most of the projects, it is the case. In delivering of most of the project, is like a relationship. You need to make concessions on your visions and the way you see things, how you're gonna deliver them. You need to be prepared to adopt and modify designs based on costs, feedback, changing project requirements, changing layout, difficulties, trying to value engineer aspects of it. Some the layouts may need to change and such, and it's sometimes a very, very difficult dance between the engineer and architect. But nevertheless, the end solution is very often a great one. And at this stage, if it's possible to get a contractor on board, and it depending on the procurement route you want to take, the contractor may just work as an advisor, as a consultant at this stage, without being signed up for the actual build. It's great to have a contractor on board to help assess on all of those different matters that architect and engineer worked on. Obviously, both architect and engineer should have an appreciation of how the building should be built. After all, we're not building it for the beauty sake of it, of just showing off our beautiful renders on paper and brag about how brilliant we are. We, at the end of the day, we need to build this building and need to build it safely. So contractor can help identify how this can be achieved, maybe in a better way than the actual architect or engineer can, giving the team the perspective and maybe drive the projects in a slightly different direction. You see, contractors can assess the feasibility of construction based on the initial concepts. They can go on site and appreciate the constraints and provide insights into potential challenges related to the construction methods, site conditions, and logistics and the operation of the actual project. They can budget estimate the chosen solution and put it in plan how it should be delivered in the most economical way. And if we at this stage don't think about what is the best way of constructing the given solution, we may be thinking about solutions that will be more expensive than they initially should be. You see, if we need to do the basement, we may pile it all around and then excavate the basement and be nice and safe that all of the ground around is, stays where it should be as we dig. But doing piles, cantilever piles, they're very expensive and they don't really need to be used if we can reduce the ground on sides, on the sides of all of the sides, if we can slope the ground or grade it a little bit so the ground becomes stable enough for the project to continue. And if you get inundated in your solution, don't think about the way how to construct it. You may well end up spending a lot of money for not needed solutions. The contractor, as I say, can input on the construction costs, the labor costs, and how the building can be delivered, how the given concept can be delivered within the budget constraints. It's also great, for that matter, to include the contractor in the whole evaluation of the concept and creation of the solution, as the ways and techniques that are available and knowledge that are available on the local contractors market, they very often dictate how the contractor will approach it. And we may got used to, as designers, for a delivery of the project in a certain way, but the idiosyncrasy of the area, for example, or all those given contractors may challenge it, and they may not be quite well versed in our solution, and it may be better to actually adjust our solution to the skills that are available in the given market. Contractors can suggest those solutions, and we can take them in consideration and make them work for the given project. They can obviously identify risks and the risk with the delivery of the project and how to mitigate those risks. We can do, as the team of 3, we can do constructability workshops where we can organize contractors and designers and other stakeholders to collaborate and refine the concept design. You see, if the project is big, there's many people that will be impacted by it for a long time. And it would be good to actually involve all of those people, not only the financial stakeholders and people that actually risk the business models, the money within the project, but the surrounding people, and bringing a social value to the area rather than just getting on with the projects and being inconsiderate to the needs of everyone around. It's important, that's why it's important to do those workshops, because you can address the constructability issues early in the design stage and brainstorm the solution. As ever, with all of those endeavors, communication and collaboration is very important. You don't want to have team members, especially at this stage, that are hanged on any given solution and without letting go. This stage is for the brainstorming, it's to find the best solution for the given scope, for the given brief, and perhaps finding the best way forward and value engineer the heck out of this project. Early involvement in the designs and design meetings of contractors gives you that perspective, give you that chance to actually deliver projects and design solutions that will be better placed in the given circumstance. And once we have that, once all of the consultants, architect, engineer, contractor, cost consultant, when everyone's happy with several different solutions, all been working incrementally, regurgitating solutions towards one and final way forward. Once we got that in place, now we can start thinking about preparing and derogating that initial brief that is now enhanced by the existence of the actual design and the actual tangible and visual asset. It's time to give some meaning to that visual parts. It's time to think about how to approach the planning, which is my point 4 on the list of things that I'd like to discuss. It needs to, analyze the site, conduct that thorough analysis, considering such factors as location, topography, access, and environmental constraints, understands the context and surroundings to place that building, how it should be placed, and so we can argue that the planning that is the best way forward. You see, that early engagement with all of the stakeholders, and not only the ones that actually driving the brief, driving the agenda of the building, but people surrounding the building. How we can bring value to these people. After all, this building is placed within their environment, and if it can enhance it, it will be better perceived by everyone around it, and it will be used better. We'll find better. We'll get to find out the expectations from people. What sort of requirements of the local area? What are the requirements of the local areas? What are the idiosyncrasies? And any other special consideration that the people may have. Sometimes it's great as a part of the given driving force, as the given money driving force. We can create some additions to the projects we never perceived before essential or needed. See, green spaces are very often a great place, but maybe aligning the green spaces with 15 minutes city concept, and we have a great circulation area for people to enjoy and maybe to have a little break as they go and travel from place A to place B. see what sort of planning policies are in place for the given area. Obviously we have a national framework, but there are those local aspects that need to be addressed too. Not all of the areas are the same, and not excluding green belts and areas of outstanding natural beauty, conservation areas, and such. There's so many different facets to these aspects of planning and how to approach it in best fashion. It's very often the time when the idea of the project is being communicated with the planning office as an outline for the discussion, so we can achieve most and best for the given project. It is the time now when we think how to reach building regulation compliance. Who do we need on board? What aspects are there? There's quite few. Not only structural soundness is important, although that's the first one on the list. We need to think about the fireproofing of the building, how people will evacuate it or not during the event of fire, how to stop the spread of fire internally and externally, and how to address all of the different aspects, taking in consideration the layout and the materials used. Obviously need to have those buildings energy efficient, and is it great to rely on HVAC approach, using electrical equipment to drive the air, drive the environment, control the environment within the building? It's maybe better to actually rely on physics, on natural ventilation, on thermal mass of the building, or perhaps combining the both, which can be the best of the both worlds. You see, from my experience, the best buildings are the buildings that are thermally stable, the buildings that don't need much of an influence to remain where they are with the temperature and the quality of air within it. So these are the buildings with good thermal mass, which are well insulated, where you can store all of that heat that you generated, rather than just heat the air and once it's gone, it's gone. We heat elements that maintain it, and the same way around, we cool elements and they stay cool for longer. So in the hot days, we don't need to rely on the air conditioning that much. How we approach the sustainability of the whole thing, how accessible and inclusive the spaces and building will be. These are all very important aspects that will have to be thought about right now, and then further develop down the road. Once we know all of that, we need to think about who will be involved in the bloody project, right? We know what we want to build. We know that we are reasonably within the budget. So it's now we need to create the team and assign responsibilities to the particular teams with particular expectations and standards and so on. See, we have our design team, which are usually architects that lead the overall design and aesthetic aspects of the building. We have our structural engineers focused on structural integrity and robustness of the design. We have our MEPs, mechanical, electrical and plumbing engineers, that addressed the mechanical, electrical and plumbing aspects of the building. Obviously we can have our landscape architects too, that will contribute to outdoor spaces and green designs. We can have our civil engineers that can concentrate on drainage and sustainable urban drainage system, where we can attenuate some of the waters in little ponds and alike, and they can work together with landscape architects or others. We might need to address the nutrient neutrality aspects of planning and think about how to create reed beds so they can filter the additional nutrients from the site. That'll be our design team, and there may be many members in there, but there are generally three. You have your architects, engineers, and MEPs. These are the three that drive it. You'll have your project manager, who oversees and coordinates all different members, manages timelines, budgets, and project deliverables when there is one on site. You have client representatives that will provide inputs on project and their goals and objectives, review approved designs, and decides on the way forward. You may think about many different specialist consultants that may need to be involved in the later stage. Specialist contractors who will design and deliver parts of the project. I think that the one most widely used and sort of the way that the British construction projects are delivered right now are the steelwork contractors, fabricators, who take the general design of steel framing, deliver the connection designs and fabrication drawings, and fabricate the build and then deliver and erect that on site. But there have been different ones as well, the ones concerned in balconies and thermally decoupling them from the building, the acousticians, the vibration specialists, some buildings, they need to be vibrationally isolated from the surroundings, like concert halls, lighting designers, or any other. There's plethora of them, and now is the time to identify who should do what and when, put them into a responsibility matrix, and go out there and find the best one for the project. It is the time now, and it is point 7, to outline the specifications of the project, what sort of materials and finishes will be used later on. Provide a broad overview of materials and finishes to be used. That's the time to specify key characteristic and quality standards for them. We need to think about the performance requirements, outline the performance criteria for various building components, specify standards for structural, thermal and acoustic performance. Think about the compliance with regulations, ensure that the specification aligns with building regulation and industry standards, include any specific requirements stipulated by regulatory authorities. We need to think about the sustainability features. How we can make the building energy efficient and what sort of systems to use. This is the part where we hone on, when we concentrate, when we put that bits together for further development down the line. And once we've done all of it, we need to check how it actually addresses the brief and whether that brief needs to change. And very often that brief do change as we go on finding the best solution forward. We usually, as we go on with the design, as we develop it, we consult the client to show him, which way we're going with the project, what we see it's important for it. We update that brief based on the client's preferences and approvals. And then we go back to the board and then we tweak it a little bit more and try to make the most of it, and then we go back to the client and do it again. We assess the feasibility of the project in more detail in terms of construction cost and compliance. And then we adjust. As I say, it's iterative process. We look into the client inputs, we design the solution or several solutions, we compare them, we talk to the client about them, we take all different aspects in consideration, we update the brief according to the findings and how we develop the building. We look at the risk associated with the updated brief, develop strategies to mitigate this risk, to ensure the project success, and we document. We need to update all of the project brief, ensuring the clarity and transparency. It doesn't happen on the word of mouth. We need to have it in black and white, so it can be contractualized and then expected and executed later on. You see, concept design is the design about that careful consideration of all of the different aspects of planning, compliance with building regulations, and collaboration among the diverse stakeholders, so we can set the foundation for a successful project. And when we regularly update the project brief, we ensure that we got that alignment with achievable goals, and we evolve the project rather than just push it forward. So there you have it. It's been a little bit long, I think, but let's summarize it all. That's around, I noted eight points that are worth mentioning, how that stage comes together. It's number one, architectural concepts. It is the concept design phase, where the architects craft the initial vision of the project. At this stage, it begins with a thorough site analysis, understanding of its context, topography, and environmental factors. It's time to engage stakeholders to ensure the design aligns with client expectations and local regulations. The preliminary designs concepts should explore various architectural possibilities, all while considering functionality, aesthetics, and sustainability of any given solution. A well-defined architectural concept will now set the stage for the project overall success. And that success comes and is achieved together, which is my point two, finding the engineering solution. Once we got the architectural concept, we can define the engineering solution for it. And the engineering solution is pivotal for turning the architectural vision into tangible structure. Early cost estimates of that solution help set realistic budget constraints, while life cycle cost analysis considers the entire project lifespan. Value engineering practices enhance functionality and quality without compromising costs. If anything, they bring better value than drive the costs. Efficient design practices such as modular design and standardized components are important and should be used as much as possible, and they should streamline construction processes. Collaboration between engineering, design, and cost planning teams should ensure that a cohesive approach fostering economically viable and efficient solution is achieved. It is great to add to that team of two, of the architect and engineer, a contractor, and that's my point three. Contractor plays a crucial role in contributing to that concept design phase. As ever, the engineer and architect, they may have their own opinions and experiences of delivering the project, but if we cannot have the opinion of the local contractor, we don't know the local skills involved, and we cannot expect all the skills of all the world being available everywhere. The contractors will conduct constructability analysis, provide insight into potential challenges and constraints of given project and a site, will give us an early cost estimation, and that can help us align the concept design with budgetary constraints. The contractor can help to value engineer and suggest optimizations to the design So to make the construction more efficient, collaborate between designers and contractors. That collaboration ensures site-specific considerations are addressed. And I think it's very important, because now we can idealize and make the best solution, but if it's difficult to be built by local contractors, and we don't have that early involvement with them, then we can lose on opportunities. And if we do involve them at this stage, project can greatly benefit from practical experience of local people, leading to realistic and efficient design. In point 4, when we already designed and defined, the core team knows what should be built and we know the way how to build it best, now we can think about delivering the second part of this stage, which is preparing all of the documentation, all of the strategy for further development and delivery. So in point 4, we think about how to approach planning. Approaching planning involves a site analysis, stakeholder engagement, and clear design objectives. Preliminary designs and concept, they explore architectural possibilities and adhere to local planning policies and ensure regulatory compliance. And this point, in a way, it does interplay with the previous 3, because you get into the right solution, but then you need to see whether that solution actually plays well with the local area, with the local planning expectations, local intricacies, and local stakeholders. So sometimes, once you get to your good solution, you put it through the sieve of the planning expectations, and then you may need to tweak it again to deliver the product, to deliver the project that will be actually acceptable from the planning perspective also. In point 5, we need to think about how to reach the building regulation compliance. And we already thought about the aesthetic aspects and organizational aspects and engineering aspect and buildability aspects of the project, but there's so much more in any given project that need to be thought about than just that. And now is the time to define how we're going to do it. And to do it, we need to thoroughly assess against the regulations, our given solution against the regulations. It may be the time to start collaborating with regulatory authorities and to consider sustainability, fire safety, accessibility of any given solution. It's time to put the team down on paper, who's responsible for what, to what extent, to what standard, and to what level of definition of the information. We need to create that responsibility matrix, which is point 6, that involves defining all of these roles, all of the teams, project managers, client representatives, and specialist consultants. We need to know what we need, from who we need it, or at least what we need to go out and find the people that will deliver for us. This matrix ensures effective collaboration and clear communication among team members. In point 7, we need to give the project the outline specification. An outline specification provides an overview of materials, finishes, and performance requirements of the project. It outlines compliance with regulations and highlights sustainability features guiding the detailed design phase. With all of that information and going back and forth between us and the clients, it's important to highlight the point 8, which is updating the project brief. As we got out from stage one, preparation and brief. We had a business case defined and showed to us. Now we develop it further. We actually gave it a tangible feel. We gave it a definition. And now it's the time to derogate that brief and align it in line with all of the findings, opportunities, and engineering solutions. Updating the project brief involves engaging with clients, and all of the stakeholders, and assure that it aligns with the preferences. And there you have it. A comprehensive overview of Stage 2 concept design, at least in the UK, at least how I experienced that. I hope this episode has provided valuable insight into the intricate process of blending creativity, compliance, and collaboration in the early stages of architectural design. Thank you for tuning in. The world of project definition is super interesting and can be complex, but like in music, when you're good with your principles and played a lot of times, it allows you to be creative and create magic with what palette of solutions is known to you and within the constraints of the budget and the site. Before we wrap up though, let me emphasize the paramount importance of carefully considering and balancing all these aspects in our design process. In many small offices, particularly on small projects, it's unfortunately not always the case that all these factors receive the thorough consideration they deserve. In Bitna, we recognize the significance of this holistic approach, even in the context of smaller projects. Our commitment is to ensure that every project, regardless of its size, gets the attention and consideration it needs. We understand that each element, from the architectural concept to engineering solutions, contractor contributions, planning, compliance, and beyond, plays a crucial role in the success of the final outcome. In my office, we strive to create a culture where even in smaller projects, these considerations are woven into the fabric of our design process. We understand that each project is unique and we adjust our approach accordingly, considering both size and complexity. Our goal is to deliver not just a structure, but a thoughtfully crafted solution that meets the client's needs, aligns with regulations, and stands as a testament to the collaborative effort of architects, engineers, contractors, and all involved stakeholders. In conclusion, the synergy of these elements is what transforms a mere concept into a tangible, well-executed reality. Thank you for joining me on this journey, and I look forward to sharing more insights with you in future episodes. As ever, reach out to me on LinkedIn. Thank you for listening. Please voice up your opinions. I want to hear from you. Toodaloo.